let z equal e to the x times sine of y, where x is a function of s and t. X is s squared minus t squared minus s minus t, and y is also a function of s and t. Y is equal to pi st. And we would like to find the partial derivative of z with respect to s and the partial derivative of z with respect to t, both at the point s equals 2, t equals 1. So we have the variable z, which depends on the variables x and y, and then the variables x and y depend on the variables s and t. So we can see that z ultimately depends on s and t, and to find the partial derivative of s with respect to to find the partial derivative of z with respect to s, we look down the tree here at the branches that will take us from z to s. We have from z to x to s, and we have from z to y to s. So the chain rule says the partial derivative of z with respect to s is going to be the sum of the derivative of z with respect to x times the partial derivative of x with respect to s, that takes care of the first branch, plus the partial derivative of z with respect to y times the partial derivative of y with respect to s. So if we compute all four of these derivatives and perform the indicated multiplications in addition, then we will get the partial derivative of z with respect to s. And similarly for dz dt. So let's calculate the partial derivative of z with respect to s. We have dz dx. So z is equal to e to the x times sine of y. So the partial derivative of z with respect to x is e to the x sine y. And the partial derivative of x with respect to s, so here's x, we'll have 2s minus 0 minus 1 minus 0. So this is the partial derivative of z with respect to x times the partial derivative of x with respect to s. And then we have plus partial derivative of z with respect to y. We'll get a cosine y, so it's e to the x cosine y times the partial derivative of y with respect to s. Y is equal to pi st, so the derivative with respect to s is pi t. And now we want the partial derivative of z with respect to s at the point s equals 2, t equals 1. So notice here we have a function of x and y, and we want to plug in values of s and t. So we could convert these, we could convert the x and y into s's and t's using these formulas, or we could just take the numbers 2 and 1 and plug them in and get the corresponding x and y. So if s equals 2 and t equals 1, then this will tell us the values for x and y. So x will equal 4 minus 1 minus 2 minus 1, which is 0. And y will equal 2 pi. So let's double check that. If s is 2, then this is 4, and that's 2, so that gives us a 2. And if t is 1, then this is minus 1 and minus another 1. So 2 minus 1 is 0. So we have then x is 0, so e to the 0, and then sine of 2 pi. And 2s is 2, so 2s is 4, minus 1 is 3. Plus e to the 0 times cosine of 2 pi, and t is 1, so times pi. And let's see, e to the 0 is 1. The sine of 2 pi is 0. So this first term just becomes 0. And here we have cosine of 2 pi is 1, e to the 0 is 1 times pi, so we get pi. So the first partial derivative is pi. And what about the second one? The partial derivative of z with respect to t. From z to t we have to go through x and we have to go through y. So we get partial derivative of z with respect to x times partial of x with respect to t plus partial of z with respect to y times partial of y with respect to t. And then we have to compute these derivatives. Partial z with respect to x and partial z with respect to y we've already computed in the previous problem, so we should make sure we get the exact same thing if we do it again independently. But here I'm just going to copy them. Partial z with respect to x was e to the x sine y. And then we have to multiply that by partial of x with respect to t. So this is 0 minus 2t minus 1. Minus 2t minus 1. And as we saw before, this whole term is going to become 0 because the y is going to be substituted for by 2 pi. So we'll just ignore this one. And then plus, we have e to the x cosine y times, instead of pi t here, it's dy dt. So dy dt instead of dy ds is pi s. dy dt is pi s. So this is pi s. And when we plug in the numbers dz dt at the point where s is equal to 2 and t is equal to 1, this first term is going to have a sign of 2 pi, which is 0 as mentioned earlier, so that's going to be a 0, plus e to the 0. We still are using this fact when s is 2 and t is 1 because it's the same numbers here, so the x is still 0 and the y is still 2 pi. So we have the e to the 0 cosine of 2 pi just like here. But now instead of times pi, it's times pi times s is pi times 2, it's 2 pi. So we get 1, 1, 2 pi. So this derivative is, this numerical value is 2 pi, and this one was 1 pi.